Hey guys, welcome to our video on alkyl halides today. This video is brought to you by VrikshOnline.in. Before we begin, please feel free to like and share our video and do subscribe our YouTube channel VrikshOnline.in. We will be talking about structural representation of alkyl halides. We will look at the uses of alkyl halides. We'll look at the classification and reactivity of alkyl halides today. Let us first begin with the structural representation. So I'll take you to the Word document and I'll write step by step to make you understand better. So alkyl halides have a very simple representation. It is Rx. Now R stands for the alkyl or aryl group and X stands for the halogen. Example of an alkyl group is a methyl group. An example of an aryl group can be as simple as a benzyl group. Examples of halogens, you know there are four major halogens that we come across in organic compounds. They are fluorine, chlorine, bromine and iodine. If we write down methyl fluoride, methyl chloride, methyl bromide and methyl iodide, I'll tell you a trend in this. What happens is, as we go down the group, the size of the atom, the halogen atom, increases. And as a result, the bond length between the carbon and the halogen increases. What happens then? The bond becomes weaker and therefore the reactivity of alkyl halide increases as we go down the group. So this is a little insight into the structure and reactivity. Next, let us move on to the uses of alkyl halides. So let me now tell you something about the uses. A most common use of alkyl halide is as solvents. So they are used for solvents. They are used as solvents for multiple reactions. The second use is very interesting. So alkyl halides are truly magic molecules. Let me tell you why. So starting from Rx, we can make a variety of molecules. We can convert Rx into alcohols. We can convert them into aldehydes and ketones. We can even make acids from this. We can convert them into ethers, epoxides, alkenes, and alkynes. That's like, wow, 7 more molecules from a same starting material. Definitely, it's a very, very important reactant and a very important starting material. Next, let us look at the classification of alkyl halides. So I'll erase this out and let you know the classification. So if we look at the basic classification, alkyl halides are classified into 3 categories: primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. Let me write in detail the structure of these to make you understand in a better way. In primary alkyl halide, the carbon containing the halogen group is connected to one more alkyl group. And the remaining are hydrogens. As you can see here, there is one alkyl group connected to the carbon containing the halogen group. So this is a primary alkyl halide. In case of a secondary alkyl halide, the carbon containing the halogen group is connected to 2 more alkyl groups. So it's like R and R dash in this case, and this makes it a secondary alkyl halide. In case of tertiary, the carbon containing the halogen is connected to 3 alkyl groups. So that makes it a tertiary alkyl halide. You can see that this is connected to 3 alkyl groups. Now let me ask you a quick question. Let's see if you are witty enough. What about this molecule? Would you call it a primary, a secondary, or a tertiary alkyl halide? Let me give you the answer. This is none of the above. Why? Let's look back. So primary is when a carbon containing the halogen group is connected to one other carbon. Now in this, the carbon containing the halogen group is directly connected only to hydrogens. So in this case, it is neither primary nor secondary nor tertiary. Now this is a very important question that comes in many competitive exams. First of all, why are alkyl halides reactive? Let us have a close look at the structure again. So alkyl halides can be written like this. There is a halogen and there is a carbon. And as you can see that the halogen is much more electronegative than the carbon. And what happens when an atom is electronegative and it is attached to carbon? It pulls all the bonding electrons towards itself. And this creates partial positive and partial negative charges in the molecule. So the electronegative halogen atom acquires partial negative charge while the carbon acquires a positive charge. What happens in the molecule then? It becomes polar. It acquires polarity, and therefore this molecule is highly reactive. What kind of reactions it will undergo? For this, we have to have a close look at the hybridization of the molecule. You can see that the carbon here is sp3 hybridized and it is connected to four other groups. It may be different, it may be same, we don't know, but it is connected to it is connected by 4 different bonds. So let us note down that. And now there are two possibilities. In a reaction, the carbon can retain its sp3 hybridization Now that happens when the molecule, the alkyl halide, undergoes a nucleophilic substitution reaction. What is the other possibility? There can be a reduction in the hybridization and so it can go to sp2 hybridization. Can you roughly guess when does that happen? That will happen when the alkyl halide undergoes elimination reactions. And the product of elimination reactions, as you know, usually are alkenes or alkynes. So this makes it clear why alkyl halides undergo only nucleophilic substitution reactions and elimination reactions and nothing else. So if you think like this, chemistry becomes really interesting. So let us just recapitulate what we learned. We learned the structural representation of alkyl halides. We learned about the uses of alkyl halides. We learned about classification of alkyl halides. And we also learned a little about reactivity of alkyl halides. So it was very nice learning about all this. And to tell you a little more about VrikshOnline.in, here's some exciting news. Enrollment for CSIR UGC NET batches have begun. So please contact us at vrikshonline@gmail.com and do visit vrikshonline.in for more information. Please do like, share and subscribe our video.